Okay, so we're on 5.2, verifying trigonometric identities. So what we're going to be talking about is just kind of like strategies. You know how when people complete puzzles, everyone has a different method of solving a puzzle, right? Some people like to do the outside. I'm an outside person. I like to do my border first. I do the entire border of a puzzle, and then I start working my way on like light colors. So things that are the same color, I piece together. It's a process when you do puzzles. And so same is going to take place here. How you solve a trig or verify a trig identity may not be the same as someone else does. Okay. Just understand that all should come out to be the same in the end. Okay. The procedure for verifying identity is not the same as that of solving equations. We're not solving for anything. We're just proving that the left equals the right and the right equals the left. We're not going to come out and say, this is theta. Okay. We won't. We just won't have a solution like that. All right. So to avoid confusion, the first method that we're going to use, which is my preferred, is where you choose a side. You choose whether you're going to do the left side or the right side to make it equal the other side. Okay. It's the one-sided verification. So when you're doing one-sided verification, you're going to choose a side that is the most complicated to make it into the simple side. So for when you look at this equation here, it says cotangent theta plus 1 equals cosecant theta times cosecant theta plus sine theta. So obviously, which side is more complicated? The right side. So our right side is our most complicated. Therefore, we're going to try to take our right side and turn it into the left side using all our properties that we know so far. So we know our reciprocal, our quotient, our Pythagoreans, all these things to try to condense it down to this. This is our goal. This guy right here is our goal. Try that again. Okay. All right. So to start off with, you want to always first, if possible, distribute. So we're going to distribute cosecant theta. So we're going to do cosecant theta times cosine theta plus cosecant theta times sine theta. Eventually, I stop writing theta. It gets on my nerves. So when I don't write it in the next step, you know why. All right. I stop writing the theta symbol into the end. It gets in my way. All right. The next thing is you want to put everything in terms of sine and cosine. So you want to write everything in terms of sine and cosine. How can I write cosecant in terms of sine or cosine? 1 over sine. So cosecant is 1 over sine. This is already in terms of cosine. Again, cosecant becomes 1 over sine. This is in terms of sine and cosine. Okay. After you have everything is in terms of sine and cosine, you want to then start simplifying. So now we're going to start simplifying. Simplify means taking fractions and making them combine as much as you possibly can. So if I have 1 over sine times cosine, that becomes what? Cosine over sine. If I have 1 over sine times sine, what does that become? Sine over sine, which is sine over sine, 1. And then now, last step is apply any of your identities. So check for any identities that can apply. So cosine over sine, what identity is that? Tangent. It's not tangent, it's cotangent. Tangent is sine over cosine. So using our quotient identity, right? We know that cosine over sine is cotangent theta, and we have 1, that we make it equal to that. So your verification is done. I'm not saying my way is the easiest way, but these are my true and tried steps that I follow. I distribute, I put everything in terms of sine and cosine, I simplify till I can't no more, and then I check for identities. These are the 4 things I've always done. Is it the only way of doing it? No. Don't come for me when you say, well, I saw this video, or it said to do this. I know it's not the only way. It's just how I work my puzzle. To me, it's pretty direct. Okay, so distribute, put everything in terms of sine and cosine, simplify, apply identities. And now we have now verified that this is a true statement.
Is that all this means is verifying?
Mhm.
Oh.
So if it doesn't match up,
Then it's not a true statement. Yep. If you can't get it to verify, then it's not a true statement. So is this a true statement? Yes. We're so smart. We did it. All right, we're ready to try again? Example number 2. Which is our most complicated? Which one do y'all want to do? We want to go left? We're going to do left this time? All right, so our goal is to make the left. We're going to do a makeover. The left needs to become the right. That's its goal. X is your theta. Yep. All right. What is Mrs. Jones' first step? Distribute. Again, do you have to follow my steps? No, you do not. You can. We're starting here. We're doing the left side. We're going to do a makeover of the left side. It wants to look like the right. So I'm going to distribute. So you get a tan squared. You get a tan squared. So that gives me tan squared plus tan squared times cotangent squared. Okay. Then after I do that, what do I do? What did I tell you? Let's Jones steps. Turn everything into what? Sine and cosine. Turn everything into sine and cosine. So tangent becomes what? Sine squared over cosine squared. Tangent becomes sine squared over cosine squared. And what does cotangent become? Do we see that? And now we're going to simplify. Simplify. Tangent. Tangent. All right. All right, what happens here? You saw me? Oh, it's not low key at all. So we're down to sine squared over cosine squared plus 1. Simplifying means I need to turn 2 fractions into 1. How do I turn these 2 fractions into 1? No. Chopsticks in a bowl, guys. I'm going to chopstick it and bowl it. Ready? I'm going to turn this into a 1 and a 1. See how I did that? Magic. Yeah, coming at you fast. Yeah, percent simplify. Cross multiply. Sine squared times 1 is? Sine squared. My rice plus cosine squared times 1 is? All over cosine squared. And now we have fully simplified. We've distributed, we put in terms of signs, we've eliminated, we've turned it into one single fraction. Last step is to apply your identities. Looking in the numerator, what identity do you see? 1. Why is it 1? Exactly. Our good old Pythagorean. Sine squared plus cosine squared equals 1. With that same thought, applying this, cosine squared also can be written as 1 minus sine squared. That's because we have sine squared plus cosine squared equals 1. And remember how we said with Pythagoras, you can manipulate this to fit whatever you need. So if I wanted cosine by itself, what would it turn out to be? 1 minus sine squared. Did we verify that the left and the right are the same? Our plastic surgery was success. According to the book, I have to show you another method. Personally, I think it's pointless, but according to my curriculum, I don't see a problem with my way of doing it. According to the curriculum, though, this was for y'all to practice. Forgot. Okay. Yeah, here's y'all's practice. The other method is example 4, somewhere. Example 5 or something. All right. Choose your poison. You gotta do left or right. Which one are you gonna do? Definitely the right.
Is T or theta?
Yes, T is your theta. Theta. Yeah, with your partner, table partner, talking it out,
That's not fair.
or as a class.
She told me.
Oh, justice.
That's not fair.
And Andrew can talk across.
Anyway.
What side are y'all gonna do?
I forgot how to do this. Like already.
So the first thing is distribute if you need to distribute. Do you need to distribute? No. After you don't need to distribute, what do you need to do? Sine and cosine.
So what do they like?
Oh, you're doing the left. Okay.
So what is like?
You can't do that. You gotta simplify now. So simplify means you gotta turn this one fraction into one. The 2 fractions into 1. A little chopsticking it out. You go from top to bottom. So there you go.
So that just equals.
So you get sine.
Does it do multiply? So it's just.
Sine to the 4
Sine to the 4.
minus.
We don't start.
Then you multiply those two. So
You multiply these two.
your denominators. So cosine squared
And then.
on the bottom.
Yeah.
So now you're at sine cosine, right? So you keep change. So it becomes sine over
That's what I'm
cosine.
saying. You got
One over.
cosine squared minus 1 over sine squared.
I think you can. So then you cross multiply.
No, remember when it's just regular multiplying, so just go straight.
Same.
You chose the left side.
Cause it's.
Hey, I know how to.
Yeah.
Hey,
It's what's
hey,
harder to you.
Simplify.
Oh.
1 over
Yeah.
sine squared.
So now you have sine to it.
Sine.
And
Isn't that just equal to cosecant squared?
still not a cosecant.
No, we got it. But you don't need this.
But now you gotta do the secant and cosecant, because that's the way you chose to go.
T,
Y'all gotta be okay to struggle.
Oh, but.
yeah, okay, so.
Okay.
1 over cosine squared.
It's sine.
Okay, 1 over cosine squared minus 1 over sine squared. You need to simplify them so that you gotta take your 2 fractions and turn them into 1 fraction. So chopstick and bowl.
How you do one? Oh, because this is 1 fraction basically.
Oh, doesn't that just make out to be one?
Which side did you do? Left or right?
I did the right. I
Okay.
did the chopsticks in the bowl and I got to here.
Where are we at?
So we
Yeah.
have
So
that.
don't talk six o'clock.
Does that look like?
So you're not.
It's because
So
then-
now we're at sine squared minus cosine squared.
It's, okay, so the bottom is cosine squared plus, multiply by sine squared, right?
Do you remember difference of two squares?
Yeah.
No.
But it was one.
Not at all, lady. Not at all. All right, so you see the little teal poster right there? The band. So when you have two perfect squares, they factor out to be.
Sine squared plus cosine squared. Oh, so the sine squared minus
Well, it's
cosine
not
squared
even
is
negative.
negative.
When this is gonna factor out, the sine minus cosine times sine plus cosine. All over that.
Ooh.
I don't know. Cause
Wait,
we
this
also
is
did
just
right,
false.
so the fact that you said difference of
Wait.
two squares is kind of crazy false.
That's what. That's what.
That's what,
When you have the square,
yeah,
I don't know the difference.
Because
me neither.
so difference of two squares from algebra two, and when you have two perfect squares being subtracted, their factors are the square root of them being added and subtracted. So remember we had x squared minus 36? Its factors were x minus 6 times x plus 6.
Oh, okay.
The same rules apply for trigs.
And then after I did that, where do I go from there? Is that it?
Does it look like the side you're trying to transform into?
No. So it's
It
not
was the hard
the same.
shit. I could've done that. It's hard too.
This one perfect.
Okay.
So,
Why did you do that?
so it's
all challenging you.
so it's sine minus cosine times sine plus cosine. If it's sine squared minus cosine squared.
For all people doing the right side, I didn't do the right side.
Oh, well,
I don't know,
the left
I
side
did the
looked
left
too
side.
complicated
Are
too.
you done with left, are you done with left side?
Well, no, I'm stuck.
Are y'all ready for me to show you my left side?
Yeah.
Because I didn't do the right side.
Can you do the right side with us though?
It looks easier to me.
Of course.
And that's why we gotta do the right side, because it's easy.
No, this looked easier to turn that into that.
Oh,
Like, to me, that was like, oh, yeah. All right, so this sense is, when you have a subtraction and one term in the denominator, you can separate these two. It's like undoing your distribution. So I can separate these two to become sine. Oh, that's not sine. This is my song, guys, sorry. Okay, I can't write the T. It's gonna start looking like tant, cent, and cost, and it's gonna bother me. I'm just gonna not write it. I'm doing the left side, it's how I initially did. Minus cotangent. See, I wrote cost. So you're undoing the distribution. I separated them.
Sine over cosine minus cosine over sine. Divided by sine. Times cosine.
Yeah, I am.
No, you separated.
Because I can't eliminate anything while they're together. Remember, you can't eliminate when things are being added, right? But if I separate and create two separate things, now this problem can have things, this side can eliminate stuff, this side can eliminate stuff. So now I can start putting everything in terms of sine and cosine. So tangent becomes sine over cosine, all over sine cos. Cotangent becomes what? Cosine over sine, and I get sine cos. What happens when you're dividing fractions? Keep change, flippity flip, right? So we have sine over cosine times 1 over sine cosine. And what happens to my sines on this one? minus, over here, we have cosine over sine. Keep, change, flip, 1 over sine. And what happens to my cosines? They cancel out. And now I'm left with 1 over cosine squared minus 1 over sine squared. What is cosine squared? What is 1 over sine squared? So did I prove that secant squared?
I think the right-
You guys are the ones who think fractions are intimidating. I think fractions are not intimidating.
Could you do this for a living?
But on the right side, you just would have gone the other way. Reverse it. So on the right side, go the other way. Secant square would become this. Cosecant square would become that. And then you're going backwards. And you're stepping, you're dividing them.
Okay.
So you drop
The chopsticks and.
it to the bowl,
Uh-huh.
then reverse back. Now you got your things in terms of time and in. You're undoing it and going the other way.
Oh. Yeah, I'll just rewrite that one.
I warned y'all that today was about puzzles. I tried to tell y'all.
Okay, going that way was kind of easy,
It was, right?
What?
The fraction was easier.
but I can see where you did it when you said you just go
Backwards, yes, when you go backwards.
See, I don't see the right side like that, going backwards. It doesn't make sense.
Only
Undo it.
thing we got to was the cosine square, and then we didn't know what to do.
That difference of two squares thing, like,
Well, because of how you had yours set up, you would have to use difference of two squares. The other method is solving both at the same time and simplifying down to one. Do we need to learn the other method? Are y'all okay?
we're good. That's.
Okay. Yeah, I was like, the other method. Oh, he's the killer. Didn't know you weren't done.
Wait,
My bad.